You guys all look really harmless when I'm sat down there, and now all of a sudden you're terrifying. I would like to give you a case study on a particular project, so perhaps a bit of a departure from some of the talks, but hopefully we'll see a lot of relevance. I've heard an awful lot of similar themes today, it's been mentioned before, and I think perhaps this might draw some of them together. The scheme I'll be talking about is Prime Hook Nature Reserve Restoration Project. It's on the east coast of America. You can see there on the screen where it's located. It was absolutely devastated by Superstorm Sandy, Hurricane Sandy in 2012. That was a hurricane that developed in the Gulf of Mexico, tracked north. Now, normally what hurricanes do is they head out to the Atlantic. On this occasion, there was an area of high pressure that blocked the path of the storm and pushed it right into the east coast. So I was going to include lots of photos of piled up cars in Manhattan that had been affected by flooding, devastated beach properties, all the rest of it. I haven't, but the storm was 870 miles wide when it made landfall with the east coast, just sort of north of Norfolk there on the coast, and which was a record at the time, and I believe a record since. So absolutely colossal storm. Prime Hook is located just north of Norfolk on the map there. And if we sort of zoom in a bit, you'll see that there's a funnel where the landfall, where the coastal processes happen. So that obviously, increases energy loads. On the right-hand side, you can see a kind of detail of the nature reserve, which there's a tiny scale at the bottom. I don't know if it's particularly easy to read, but we're looking at an extensive line of coastline and a large freshwater and saltwater habitat. So looking at some historic photos, we can see back in the 60s, a sort of nice mature dune system on the right-hand side. By 2002, again, that dune system's still pretty intact. There's quite a lot of properties at the bottom there. By 2007, at the top there on the right, you can see some overwash of the dunes happening. So the dunes are starting to retreat inland. And by 2009, there's some morphology happening, so it's breached, and there's more overwash happening. And 2011, again, there's a little channel there happening and some more breaches happening. So certainly something moving there. But if we look at the next photo, which is post the storm, we can just see that there are huge holes in the dune system. What that initial breach is actually closed up. There's a significant change to the morphology has happened. And basically what was a really important sort of freshwater and intertidal reserve is now basically part of the sea. What we see is essentially a tipping point from a geomorphological point of view. And this is a significant and profound change. And obviously the whole lot is going to profoundly change, and it's not an intervention. At the top of the photograph there, you'll see on that peninsula, there's properties up there. So there's a road up there. Those properties were only accessible at low tide. We've got some really significant issues to deal with. So a team was put together. Stan Tech obviously part of that team, and Jeff Tabar, who is our US coastal lead, played a very significant role in that team. And so this statement comes from him, and it's American, so I'm not going to say it in American accent, but it's got a real, can-do vibe about it. So the mission, restore and reinforce our coastline using elements that will naturally complement and fortify the local environment. What I'd like to do is just unpick that for a second. So firstly, a mission, well, we've talked about that. This is a reactive project. This is not something that's part of a strategy or plan. This is something that's happening in real time and needs sorting out. Restore and reinforce, so it's not just to put back the dunes prior to the storm, but to come up with something that will be resilient in the future. And we'll see later that they modelled Storm Sandy as part of the kind of design criteria. So the idea is to come up with something that will be resilient in the future, using elements that will naturally complement. So it's adopting that systems approach. So we're not just talking about individual elements. It's not just we'll build up the sand dune. We need to consider the hinterland, the marsh behind. We need to consider the flow of salinity. We need to consider habitats. There's all sorts of things to consider. naturally complement the local environment. Local environment, this is not some generic approach, this is a specific local approach, even though it's a fairly large area. And in terms of naturally complementing, there was a bit of a conversation earlier about what nature-based solutions are. And from my perspective, they are solutions that work with natural processes as much as possible. So again, a systems approach was adopted. There were numerous stakeholders in this environment, as you might imagine, lots of opinions, lots of politics. To manage that, especially in a fast-moving reactive environment, as like a technical advisory group was set up that consisted of local academics, scientists, residents, regulators, agencies, the people who worked at the wildlife reserve, basically a sort of meeting of the minds on everyone who might have something useful to contribute. And they formed like a stakeholder panel right at the start. And they were able to then fend off an awful lot of, well, why are you doing it like that? Or could you just do this? Or once that group was in alignment, it was very, very powerful, and it built an awful lot of trust very quickly. And when it came to getting regulatory approval, a lot of the pre-work had been done. So it's something that when I've delivered projects, I've tried to do, and it's been with varying degrees of success. And it's something that is a real, I think for me, an aspiration that I would love to get all these parties together in a room on a regular basis to just talk through what the issues are, and everyone can see that what we're doing is based on the best data, based on the best evidence. I know we're short on time. If you're interested in the detail of the technical modelling, come and see us afterwards at the stall, and I won't dwell on that now, but I did mention that we used Hurricane Sandy as a kind of extreme case event. So delivery. Two parts. One is the marshland restoration, so 30 miles of conveyance channels were dug, dredged. The sediment was placed over a large area, I think 10,000 acres. No apologies, by the way, for using cubic yards and miles. It's an American scheme, you've got to get used to it. They're just cool, right? A cubic yard is pretty cool. So yeah, 600,000 yards of cubic sediment. 1.1 million cubic yards of sand along the shoreline. That was from an offshore borrow area just in front of the scheme to create a 40-foot wide dune and the beach berm. So we've got basically the near shore or coastal protection, and then we've got the inshore consideration. The scheme was completed. It had restored a couple of miles of shoreline, 10,000 acres of marshland, 22,000 tonnes of carbon sequestration. We've got increased resilience for storm protection. The properties are protected. You can read what it says. The other thing I'd like to say is that this Storm Sandy happened in 2012, and this was on site in 2017. So we're asking what we can achieve in 5 years. And that's regulatory approval, the lot, getting a scheme on site. So I think it's a really interesting example of when people are really, really focused and pulling together with the mission from the States approach. Quite remarkable things can happen in a very short amount of time. So why do I think this is an interesting case study? It's a recovery project. It's not planned. So a team has to form very quickly and get together. I think we're going to see big storms in the future. We're going to see larger storms. They're going to be more frequent. We're going to see more recovery projects. I think getting good at recovery is something that's really worth considering. It was a really, really collaborative effort. The regulators, residents, scientists, engineers, everyone pulling together the same thing. Heavy focus on working with natural processes. The modelling was there to understand what nature would do, because that's the environment we're leaving these schemes in. It's a natural environment, so we have to understand it. We have to work with it. Nature-based solutions are absolutely the way forward. And also, what this dune is, it's a barrier island, essentially. When we often think about the coastline as being the line that we've got at the moment, but I'm not sure it's fully part of our toolkit to just think forward a little bit into what is currently wet and thinking, well, can are speed bumps something that we can use for coastal erosion, for coastal management in the future? I think the idea of a barrier island is a very novel one, worth considering as part of the toolkit. Anyway, that's it from me. Thank you.